All right, we're back. We're in Calc AB Notes 7. We're on page 3. We're doing related rates. So you usually have to draw some kind of picture based on some kind of geometric situation. Then you just kind of go from there. So let's see if we can do this problem. So a hot air balloon rising straight up from a level field and is, okay, so that's not a sentence. A hot air balloon is, maybe there should be an is. Let's do that. A hot air balloon is rising straight up from a level field and is also being tracked by a rangefinder that is 400 feet from the liftoff point. Okay, so what does that mean? So it's on the ground and it goes straight up. And then when it's on the ground, the rangefinder is 400 feet from it. So I think that's what that means. So I think we have another triangle situation. At the moment, the rangefinder's angle of elevation is pi over 3. The angle is increasing at a rate of 0.2 radians per minute. Okay, which maybe that's fast. 0.1 radian is like almost 60 degrees. It's like less than that. So 1/10 of that would be 6. So like 12 degrees per minute. I don't know. I have no sense of that. I think that's probably fast, maybe. Let's try to draw a picture though. So we have our balloon. There you go. That's our balloon. We have a rangefinder that is 400 feet away. Okay. And then what are we trying to find? We're trying to find the rate at which the balloon is rising. Okay, I mean, I'm going to finish the triangle because, you know, that's what you do. All right, so it's going to be a right triangle. They're almost always right triangles. There is like a law of cosine scenario where they're not a right triangle, where it's not a right triangle. But we haven't run into that yet. I don't know if we do in the notes or if it's in like the FRQs or we do the practice problems sometimes from mastermathmentor.com. Highly recommend it. There's probably one in there. I think there's definitely one in there. All right, let's see. Rate at which the balloon is rising at that moment. So let's call it y because it's vertical. That makes sense. Now the rangefinder doesn't move. So the distance from the takeoff point to the rangefinder is always 400 feet. So we can actually sub that in. We do not need to make that a variable because if we did, its rate of change would just be 0. And so we're doing like a lot of extra work that we don't really need to do. So what are we doing? We know, so we have a theta, right? Because the angle, so you're tilting to like keep the thing in view. You're tilting, so I'm gonna say that this is theta. Okay, and we know that theta is gonna be pi over 3. We know that the rate of change of theta, d theta dt, is positive 0.2 radians per minute. Doesn't really matter. You have to be in radians. If you're not in radians, the derivatives of the trig functions don't work, right? So we have to use radians for this, but everything was given in radians, which is really nice. Now I need a relationship. So I need something that relates the side opposite a triangle, an angle rather, side opposite an angle to the side adjacent to the angle. That feels like a tangent situation to me. So I'm going to say that the tan of theta is y over 400, because it is. Oh, and what are we trying to find? We're trying to find dy dt. So there's a t and a theta in here, which when you're in like pre-calc math analysis, you frequently just use t instead of theta. Not when one of them's time and one of them is the angle. Then you have to be really careful. All right, I think we're ready to find a derivative. So we don't actually know the value of y, which I guess we'll have to work out. But this is actually, so pi over 3 is 60 degrees. This is actually a 30, 60, 90 triangle. So we'll be able to figure it out like pretty quickly. So let's see. So the derivative of tangent of something is secant squared of that thing times the derivative of that thing. And theta is the variable, and so its derivative is d theta dt because t is actually the independent variable. And then that'll be equal to, I'm going to say 1 over 400 times the derivative of y is dy dt. So I'm skipping the step where I write d dt of both sides. I probably should be writing that because you really want to keep track of the independent variable being t. So all your derivatives are with respect to t. But like all the givens and everything, I just have bad habits, so they're really hard to break. We're looking for dy dt. We know right now. So what do we know? We know, I know d theta dt, so I'll be able to sub for that. I know what theta is. So theta is this, so I'll be able to sub for this. I don't know what, that's actually all I need, right? So to find secant of theta, I have two choices. I can remember that the cosine of theta is, the cosine of pi over 3 is 1/2, so the secant is 2, and blah, blah, blah. The alternative to that is cosine of pi, yeah, cosine of pi over 3. The alternative to that is I can look at my triangle. So I'm gonna do this, right? This is actually 30 degrees and 60 degrees. So the side opposite 30 is 400. So this, if I had to find it at that exact moment, would be 800. And then this would be at that exact moment. So I actually know that y is equal to 400 root 3. But it turns out it's x root 3, 2x. That's like the ratio of the sides in a 30, 60, 90 triangle. So I'm using special triangle there. But I actually I don't really need to know what y is, but if I did know what y was, that would be helpful. So what I'm going to do is I'm going to say, why do I feel like, oh, I see what it is. Please, just calm down. All right, let's see if we can sub in here. So I'm going to say that the secant of theta, so I'm going to use the triangle. Secant is the reciprocal of cosine. Cosine is 1/2. So secant is 2. So this is going to be 2 squared. Where should I do this? Let's do this up over here. So it's going to be, let me write it down over here though. Secant of theta is 2, right? And so 2 squared d theta dt is 0.2, but I'm going to say 1/5 because I don't really want to use a calculator and it's like a little easier. 400, well, 1 over 400. And dy dt is what we're looking to solve for. So that's 4 over 5, and then times 400 is equal to dy dt. So 400 divided by 5 is 80. So 100 divided by 5 is 20, and then there's 4 of them. So 80 times 4 is 320. So I'm going to say dy dt is 320. Okay, 320 what though? So the distances are all being measured in feet, we can see. And then time is being measured in minutes. So this is going to be in feet per minute. So feet per, where'd it go? Per minute. So you want to make sure you have to get the units right. You got to think them through, make sure you're doing them right. So I think this makes sense, right? You're launching, it's going up. It makes sense that it will be a positive thing. It's probably going really fast because 0.2 radians per minute seems pretty fast. So let's see if we can answer the next part. Find the rate at which the distance between the balloon and the rangefinder is increasing at that moment. Okay, so on your figure, even though I put in 800, it's only 800 at that exact moment. In general, this is a quantity that can change, so let's call it z. And now this is a problem that we've basically done before. So two options that I can think of. We can do the Pythagorean theorem. So we could say that 400 squared plus y squared is equal to z squared. And then the derivative with respect to t of both sides. Look at me writing it in. Hopefully look at you writing it in, doing the good work. The derivative of 400 squared is a number, right? A constant, so the derivative is 0. So this will give me 2y dy dt, and then 2z dz dt. So actually, and we're trying to find, so we want to find dz dt. So we know dy dt because we just solved for it, but we're using an answer we solved for, but like there's kind of, I think there's almost no alternative here. So what can we sub in? I'm going to say that y is equal to, at this exact moment, y is equal to 400 root 3. So 400, where is 400 root 3 coming from? It's up here when we use the 30, 60, 90 triangle. We had 400 is opposite 30, so 400 root 3 is opposite 60, and then 800 is opposite the right angle because it's x root 3, 2x, if you don't remember that. So this will be 400 root 3 is equal to, so I divided out the 2's. There's a 2 everywhere, it doesn't really matter. Z is 800 at this moment. And then dz dt is what we want to solve for. So I'm going to get dz dt is bizarrely just radical 3 over 2. That seems very wrong. Oh my god, I forgot dy dt. That, I mean, it seemed very wrong, and thank goodness I had that thought. So what could I do here? I'm gonna like lasso this and move it over so that I can squeeze in the value of dy dt, which is what? Do we know dy dt? Oh wait, dy dt is, oh, dy dt is huge. Dy dt, we already had this conversation. Dy dt is the answer to the last problem. It's 320. So we'll get 400 and then 320 equals 800. Okay, I'm feeling like better about this. So this will be, what do I want to do though? Dz dt is, all right, 400 divided by 800 is 1/2. So that's root 3 over 2 times 320. 320 divided by 2 is 160. So I think it's 160 root 3. And then this, z is a linear measure, so it should be in feet per minute. Feet per minute. Okay, so this I believe is one, and I guess I should highlight it in that obnoxious color that I've been using for that. I get this. This is one way we can solve this problem. I think there's another way that we can solve this problem, potentially. So maybe not. I don't know. Let's try it. So I want to try to use like some right triangle trig on this. So what do I know? I'm given stuff about y and I want stuff about z. So I feel like I should just say that the sine of theta. So I'm going to try this. I'm going to do, so new-ish problem, same problem, different way. I'm going to say the sine of theta. I'll probably show a little less work on this. Sine of theta is y over z. So do I want to do this? You know what? I should do cosecant. Cosecant would be z over y, and I'm looking for dz. You know what I'll do, though? I'm going to find, I'm actually just going to like change it into that. So z is equal to, do I really want to do this? I don't know if I want to do this. Negative cosecant cotan, and then there's like other stuff involved, and it's kind of terrible. Let me see. So the derivative of this is cosine of theta, d theta dt. D theta dt has got to be in there now. And then this is a quotient rule problem. I don't want to do this. Do I want to do this? Like I could have brought z over and done a product rule problem. Either way, it's like not super great, and we already have the answer. Here we go. Bottom, derivative of the top, minus top, derivative of the bottom, and all over the bottom squared. Okay, so what numbers do we know for sure? We got 800 squared. There's just too many numbers here. So it's going to be 8. Oh my God, I don't want to do this. 800. You know what I'm gonna do? I'll use a calculator just to see if this is working. And then maybe I'll cut the video and then I'll come back in the next one, fill in a unit circle, and then do something. So let's see how this goes. I don't even have a calculator page up. Okay, here we go. Calculator, and I'm gonna try to like fill in the values. So right now I have cosine of theta. So I'm gonna use t for that, which is really bad. And then d theta, so times d theta. And then what I'm going to do is like substitute things in. So that's over 1 because I accidentally did that. Z times dy minus y times dz over z squared. Okay, so I've typed in, I'm using dt is my d theta dt, dy is dy dt, dz is dz dt. And then t I'm using as theta, which is not great, but it's what I'm doing. So, okay, so I know that t is going to be pi over 3 at this minute, at this like exact second. So I'm just going to sub for that. What else do I know? I know that dt, so such that dt is going to be 0.2 because that's the rate of change of theta with respect to time. I know that dz is what I'm trying to solve for. So I know that y at this exact moment is 400 square root of 3. I know that the rate of change of y, so such that dy is 320. I know that, what else do I know? I know z is 800. I really kind of hope this gets the same answer because otherwise this is going to be so annoying. And I need to solve this for, solve the answer for dz. And I get, oh God, I get a decimal. Why do I get a decimal there? Oh, look at that. What if I change, I'm going to change this instead of 1/10, which I'm not really sure why it's saying 1/10. I'm going to make it 1/10. And then I'll solve that for dz. And it gives me 160 root 3. Yeah, which is exactly what we got last time. So it will work. Do you want to do it is the real question. I didn't want to do it, it turns out. But this, it is an effective way. This will work. So I'm going to put a note. This will work, but it's awful. Right? You got to sub in for so many things. The other method, the right triangle method, Pythagorean theorem type thing, way better choice there. No way to know though until you start going. So I'm going to cut the video here. I'll come back in the next one. We're going to fill in a unit circle. That's pretty exciting. I probably won't be able to do it very fast on this iPad. And that's sad, and everybody can make fun of me, and that's totally fine. But I will see you in the next video when we do that, and then go to the next page. So see you there.